practice continuity with piecewise functions. So just a quick review of what continuous means. At this point, all you need to think about with continuity is being able to draw a function without lifting your pencil. So if you can draw it without lifting your pencil, then a function is continuous. So you can't have any holes, you can't have any vertical asymptotes, et cetera, et cetera. So your y coordinates need to match up with all of the y coordinates next to it. So like if on this side, I'm approaching a y value of 1, then on this side, I should also be approaching a y value of 1. And all of my points need to be right next to each other in order to connect. So when you have a piecewise function, that's what you're looking for, is how to make your points connect. So like here, we've got x values less than -2, and then here you have the x values greater than or equal to -2. So we've got the x value, and in order for the points to match up, we need the y values to match up. So if I plug in -2 into my the top part of my piecewise function, that's going to be -2 plus 3. That needs to match up to, if I plug in the x value of -2 into my lower function, a minus -2. Because again, I need the y coordinates to match up at this x value. So I can go ahead and solve this. And I get a is equal to -1. Okay. Now I'm going to do the same thing. I need my y values to match up at x equals 3. So if I plug in x equals 3, so I have a, which I actually already know is -1. So I have -1 minus x. So now I'm at an x value of 3. That y value needs to match up to b plus 2x. Okay. So -1 minus 3 is -4. b plus 6, subtract 6. I get b is equal to -10. So these are the two values, and you can plug them in and just double check by plugging in x is -2 into these two functions and plug in a is -1, make sure the y coordinates match up. And then same thing here for 3, if you plug 3 into these two functions, the y coordinates need to match up. So you can always check your answer as well when you are done.